Hello, welcome back. This is Unit 1, Lesson 11, Review. We are on our final target goal of I can use equivalent fractions to add and subtract fractions by estimating sums and differences of fractions and mixed numbers and using the estimate to decide whether my answer is reasonable. Good mathematicians always make sure their answer is reasonable. Does it make sense? Is this answer reasonable to what I'm doing? It saves a lot of time and mistakes. Some key vocabulary that you should be able to understand is estimate. When you estimate, you find about how many or about how much often by rounding or benchmarks. So when we're going to estimate a sum or difference, we want to know about how much it is. Benchmark. When we say benchmark, we're talking about a point of reference used for comparing and estimating. The numbers 0, a half, and 1 are common fraction benchmarks. We call them benchmarks because they just kind of are a reference for you. Like someone might say, hey, I'll meet you over by the park bench. Or I will meet you by the big oak tree. Well, in math, we're using numbers that are easy to use. All right, so when we're using for fractions, we think of the fraction around, is it really hardly anything close to 0? Is it closer to about half? Or is it closer to 1? Because those fractions are easy to use. Rounding you've used quite a bit. It's change a number to a nearby number. When I use a benchmark, I use the benchmark to round my number. Examples of rounding. 54 and 72 hundredths rounds to the nearest 10 is 50. 54 and 72 hundredths rounded to the nearest ones is 55. And 54 and 72 hundredths rounded to the nearest tenth is 54 and 7 tenths. How does it work? When I'm rounding to the nearest tens, it takes 5 ones to be halfway or further. See, we're still using the benchmark halfway. It takes 5 ones to be halfway to another 10. Since I don't have 5 ones, I just round down to 50. When rounding to the nearest ones, it takes 5 tenths to be halfway to another 1 whole. I have more than 5 tenths, so I round up to 55 ones. When I round to the nearest tenth, it takes 10 hundredths to make a tenth. So 5 hundredths would be halfway, and I only have 2, so I'm not there. Now when I'm doing it with a fraction, it's the same thing. 7 ninths. Well, half a 9 is 4 1/2. 7 is more than 4 1/2 ninths, so I have more than half for my fraction, so 3 rounds up to 4. So, taking a look at it, how do I use 0, a half, and 1 benchmarks to estimate? Well, the best way for me to show it is to use a number line. If I think of my number line going on forever to the left, going even down into the negatives, and forever to the right, getting higher and higher, infinite number of numbers, I can break it into some parts of my benchmarks. Think of 0 here and 1 here. So I'm not going very far in my number line. The very middle would be 1/2. So as I'm using 3/8 plus 5/6, I'm going to think, where is 3/8? Well, I know 4/8 is half, so 3/8 is about right here somewhere. All right, 3/8 is 1, 2, 3/8 from 0, but 1/8 from a half. So it's close to a half. So my estimate, 3/8 is about 1/2. Plus 5/6. Well, 5/6 is about right here. It is 1/6 from being a whole and 5/6 from 0. 3/6 is half. So 3, 4, 5, 6 would be there. It's 2, 1, 2/6 from half, 1/6 from a whole. It's closer to a whole. Now look at how easy that is to add. 1/2 plus 1. Well, that would be 1/2. Now, in teaching this with a class, I would be teaching how do we explain our estimate. And I like to use this sentence starter. So students every time can say this. Using benchmarks, because I use these benchmarks, my first fraction, 3/8, is close to, we said 1/2. And my second fraction, 5/6, we said was close to the benchmark 1. So the estimate is 1/2 plus 1 equals 1/2. And this is what I would ask students to say every single time. Using the benchmarks, and then whatever my first fraction is close to whatever benchmark, and whatever your second fraction is close to whichever benchmark, and then show your estimate. Now, let's just see how we would use this. Let's say, so I would, and really I do this mostly in my head. Now, if I was working this problem, I'd say, okay, I need a common denominator, 6 and 8. 6 is not a factor of 8. 1 is not their only common factor because I know they have 2 also. So I can use a multiple less than 6 times 8 is 48. So I think of my 6's, 6, 12, 18, 24. So I can use 24 as a common denominator because I know my facts. Maybe you had to look on a multiplication chart. Think of my multiplier. What multiplied by 8 is 24? Is 3. So what fraction is equal to 1 that has thirds? 3/3 equals 1. So 3 multiplied by 3 is 9/24. What multiplied by 6 is 24 is 4. It takes 4/4 to make 1. 5 multiplied by 4 is 20. Now I add 20 plus 9 is 29 24ths. Which equals 24 of these make a whole. So if I take out one whole, or actually I group one whole, that's taking 24 of these out. I have 5 24ths. And 1 and 5 24ths. Now, I would say 1 and 5 24ths is pretty close, is closer to 1 than it is to 1.5. But considering I rounded both of mine up, it makes sense. So I would say it's reasonable. Let's take a look at using benchmarks with subtraction. And I'm going to grab my oh, it won't let me. What did you let me? Okay, I'm going to grab my number line with my benchmarks on it. Because, okay, rounding using benchmarks to estimate subtraction. Really not any different. Except, here I also threw in a mixed number. So 1/6. Well, 1/6 is about here. It's 1/6 from 0. Half of a 6 is 3/6, or half in 6. So it would be 1/2/6. It's only 1 from 0, so it's closer to 0. So the fraction part is close to 0. My 9 still stays 9. Remember, when rounding down, all the greater stuff stays the same. Now, 3 3/4. 3/4 is right there. Half of a fourth in fourths are 2/4. So 3/4 is 1/4 from half and 1/4 from a whole. So when they're the same, we usually round up. When it's halfway, we usually round up. So we're going to say 1. So I get 9 subtract 1 is 8. Using rounding, my first number, 9 1/6, ended up being close to the benchmark 9. And my second number, 3 3/4. Oh, I made a mistake there, didn't I? Good thing we caught that. Good thing I'm saying this. 3 3/4. So if this part is 1, I need to add that to the 3 would be 4. So I should have went 9 subtract 5 is, or 4 is 5. Trying to go quickly here. Sorry about that. And that's one of the reasons why we do all this, is to make sure we don't make mistakes. And even when we do, we catch them then. So 3 3/4 rounds to 4, because the fraction part is close to 1 more than 3 is 4. So I really have 9 subtract 4 is about 5. Now let's actually do the problem. 6 4. 4 is not a factor of 6. 1 is not their only common factor because they're both even. They have 2. So I'm going to think of my multiples of 4 till I get one that's a multiple of 6. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 6 times 2 is 12. So my multiplier, I want to change 6 into 12s by multiplying by 2. 2 halves is a whole. So I have 9 and 2 12ths. That I got by going 6 multiplied by 2 is 12. 1 multiplied by 2 is 2. Subtract. I said 4 multiplied by 3 is 12. And 3/3 makes 1 whole. 3 multiplied by 3 is 9. Keep my 3. Remember how I forgot to do that before? 3 multiplied by 3 is 9. 4 multiplied by 3 is 12. Now, 2 12ths subtract 9 12ths. All right, I don't want to go in the negative, so I'm going to have to get some more here. I'm going to ungroup one of my wholes. That's going to give me 12 more 12ths, plus the 2 I already had make 14 12ths. 14 subtract 9 is 5/12. 8 subtract 3 is 5 and 5/12. That's really pretty close to 5.5. 5 is reasonable. Woohoo! Remember, I'm just looking at a ballpark area. Estimating sums and differences. So let's take a look at just a couple examples. Maybe I won't do all the sums and differences, just the estimating. A fourth. So a fourth is there. 1/4 is 1/4 from 0. It's 1/4 from a half. So it's right in between. I'd estimate it as about a half. 7/8. 7/8 is right about here. It's 1/8 from a whole. And half is 4/8. So 4, 5, 4, 5, 6, 7. It's 3/8 from half. It's closer to 1 whole. A half plus 1 is 1.5. And when I actually find my sum, I'm going to remember that, hey, I rounded both of them up, so it's going to be really less than 1.5. So they're coming at some bigger denominators here. 7/16. So again, I'm going to think, what is half in sixteenths? 8/16 is half. Well, 7/16 is 1/16 less than 8. So it's only 1/16 away from a half. 5/12. Well, what's half in twelfths? 6/12. So it's really close to right there. It's just 1/12 away from a half. So I have about a half, subtract a half. Their difference is really hardly anything, isn't it? So I'm going to have a very small difference. Five sixths plus 9 tenths. Half and 6 are 3/6. A whole and 6 are 6/6. 5/6 is 1/6 away from 6/6, so it's close to a whole. 9 tenths. Half and tenths are 5 tenths. A whole and tenths are 10 tenths. I have 9 tenths, which is just 1/10 away from 10 tenths. So it's close to a whole. This sum should be close to 2. It's the same page. Here's some more. Mixed numbers. 5 2/3. Now, let's see if I can. I can't. Let's do this for you guys. Let's grab this nice little piece, though. All right. Whoa, it got big, didn't it? It's all right. We can scooch it down. Okay. 5 2/3 subtract 3 1/6. 2/3. I kind of like having an odd one to talk about. So 2/3. Half of 3. here's what I do. If you don't know what half of 3 is, think of what 3 is around. It's between 2 and 4. Half of 2 is 1. Half of 4 is 2. So what's in the middle of 1 and 2 is 1.5. So 2/3 is just a half of a third away from a half. So, and it's a whole third away from one whole, because in a whole, it's 3/3. So 2/3 is 1/3 from 3/3, but it's only half a third, so it's close to a half. Keep your whole number, 5.5. Now 1/6. Half of 6. And to find half of something, we're dividing by 2. Half of 6 is 3. So 1/6 is 1/6 from 0, but 2/6 from a half. So it's closer to 0. So 3 and 0 are just 3. 5.5 subtract 3 is 2.5. Now, even numbers are usually a little easier. Half of 4 is 2. A whole and fourths are 4. 1/4 is right in the middle. It's 1/4 from 0, and it's 1/4 from a half. So I'm going to go with a half. Keep my 1 whole. 2 and 7/10. All right, so as I'm looking at tenths, half in tenths, half of 10, 10 divided by 2 is 5. A whole in tenths are 10/10. 7/10, somewhere right in here. Well, 5, 6, 7, that's 2/10 away from a half. 10, 9, 8, 7. Ooh, see, I thought it was closer to 1, but now when I counted, it's actually 1, 2, 3/10 from a whole, so it's closer to a half. So I'm going to keep my 2 and 1/2, and my estimate is 1 plus 2 is 3, a half and a half make 1 makes 4. And if we were doing this exercise, we would be then finding the actual sum and seeing how close it is to 4. 3 and 3/8, subtract 1 and 3/16. So 3/8, a half in eighths. Half of 8 is 4. 1 whole in eighths are 8. 3/8 is less than 4/8. See, 3 takes 1 to get to a half. It's 3 from 0. So it's closer to a half. Keep the 3 wholes. 3/16. Half of 16 is 8. A whole in 16ths are 16. 3/16 is somewhere in here. 3/16. 1/16, 2/16, 3/16 is 3/16 from 0. 8 7, 6, 5, 4, 3. 1, 2, 3, 4, 5/16 from a half. 5/16 is greater than 3/16. It's closer to 0. So 0, 1, and 0 are just subtracting 1. 3.5 subtract 1 is 2.5. Okay, I'm going to show you one more on this page because I want to do an odd again. 9/10. By now, a lot of you are able to just say, oh, I know which one is closer to. I don't expect you to use a number line every time, but until you get familiar with it, I would say this is a good method. 9/10. Half of 10 is 5. So I have more than half, so it's somewhere in here. A whole and tenths are 10. 9/10 is right here. Ooh, 9. That's just 1 away from 10/10. But 5, 6, 7, 8, 9. It's 1, 2, 3, 4/10 from a half. Why am I writing ninths? Tenths. So 1/10 is less than 4/10, so it's closer to 1 whole. Is my answer reasonable? Explain my answer. So this is close to 1, and 2/5. So this is what I really wanted to show you. Half of 5, remember, think what is 5 in between? 5 is in between 4 and 6. Half of 4 is 2. Half of 6 is 3. Between 2 and 3 is 2 and 1/2. One thing I teach students all the time is say, just think down 1. Down 1 from 5. Think of 5 as 4 and 1 more. Half of 4 is 2, half of 1 is a half. So if you just think of each odd number down to the even, and then put a half onto what half of it is. 2.5. So 2 is less than a half, so I don't worry about this part. I'm thinking down here by 0 is 0/5, right? Well, 2 would be here, and it's only a half a fifth away from a half. 1/2 of a fifth. But it's 1, 2/5 from 0. And this is all being in my head, so I don't mind how sloppy it looks. But, so it's closer to a half. So 1 subtract a half should equal a half. So is their answer of 1 3/10 reasonable? No way. Not even close. So my answer here, I would say no. And then I would use that sentence starter from the beginning. 9/10 is close to, and this will never fit on here when I'm trying to write with this, but is close to 1. And 2/5 is close to 1/2. So well, actually, I wouldn't say so yet. 1 subtract 1/2 equals 1/2. So 9/10 subtract 2/5 is not close to 1 3/10. And now, if I was doing this problem, and this is very possible, is I did this problem, in my head I estimated, and I'd say, oh, that's not reasonable, I'd redo it. So let's redo this one. 9/10 subtract 2/5. 5 is a factor of 10, so I can keep 9/10 the same. What multiplied by 5 is 10? 2. So 2/2 is a whole. 2 multiplied by 2 would be 4/10. 9 subtract 4 is 5/10. Oh my gosh. Look at that. 5/10 is a half. So it actually is a half. Just like our estimate. Now I can simplify by dividing by 1. What can 5 and 10 be divided by? 5. See? It is 1/2. All right. So good luck with estimating sums and differences. Just use a benchmark. Figure out what is a half, what is a whole, how far are they from 0, how far is it from a half or a whole, which one is it closest to. Once you make them into a half or a whole or 0, they're super easy to add or subtract. Good luck. If you need any help, please contact your teacher.